Hello, my name is Ron Shook, and today I will be showing how to load a particular gene, in this case the barley cap gene, mixed with loading dye into a gel so that we may perform gel electrophoresis. With the cap gene, the two alleles are of different base pair lengths and so can be differentiated with a properly run and exposed gel. I'll start off by pipetting out some loading dye. I'll point out I have a labeled piece of parafilm and I have samples from my 6th biology section that I will be mixing with the loading dye. But the first thing I'm going to do is put 3 microliters of loading dye for each sample that I will be running through the gel electrophoresis. So now I've got loading dye on my parafilm. I'm going to set this aside for just a moment. And now what you see is the gel electrophoresis tray. It's filled with a buffer, and that buffer covers a gel that I have placed in the box, and the welds for my gel are located right here. So the first thing I'm going to do is grab my pipetter, and we're going to load a ladder. A ladder works like a ruler in that it will leave bands of specific base pairs that you can then compare your gel to. So on this gel, I'm going to skip the first 3 welds that I see. I only need to load 7 samples today. The 4th well in, though, which will be right about there, I am going to put in a ladder. I try to get this tip actually into the well, and it has loading dye, so the sample does sink down into that well if I do it properly. I will be skipping 1, 2, 3, 4, 5, 6, 7 welds for my sample. On the 8th well, I'm going to put a second ladder. And that's nice just in case there's a little tilt to our gel box. So a little of this ladder is floating away. That's not a problem. The majority of it did drop down into the well. And now I'm ready for my cap gene to be loaded. And I will put 10 microliters, mixing that cap gene with the loading dye. I'll retract and expel the mixture a few times to homogenize the mixture, to mix it, and then I will load. I will need to change tips each time because we have a particular allele we're after in each of the samples. Okay, so my sample number 1, we go into our PCR tube, and we retract 10 microliters. We come over here. I'll mix. We get a blue color, which is good. We have some DNA there. And I've been homogenizing. And now we will get as much of the sample in as we can. Now it's time to load, so I'm going 1 to the right of my ladder. Get that tip just inside the well. Things will drop with that loading dye. So we are loaded up on sample number 1. I'm keeping my cap genes in their PCR tubes on ice as I do this. I'm going to go grab another sample, and we'll show you a couple more loads. Sample number 2, withdraw from the PCR tube, homogenize with a loading dye, get about 10 microliters in my pipette tip, go to the next open well, and expunge, and we're good. Loading third sample. Sample number 4. Done. Number 5. Good to go. Sometimes you get a few bubbles in there. They can be either pushed to the side or popped with your pipette tip. This one's going to settle for being pushed to the side. Sample 6 going in the well. And finally, we'll load up sample number 7. Now, the loading die is going to allow two things to happen. It's going to weigh down or increase the density of the DNA mixture so that the DNA submerges in the well and will run through the gel as opposed to over the top of the gel. And also, there is a blue dye so that as the gel electrophoresis proceeds, we can see where the leading edge of the DNA is. If I run the electrophoresis machine long enough, I will run the DNA all the way across the gel, and that will defeat the purpose. The purpose of this is to get distinct bands based on different base pair lengths. So generally, I run at about 100 volts for about 45 minutes with my particular agarose mixture, and that's going to give me good results. So we're going to load this up now. We've got the amplicons loaded and the gel box sealed like this, and it's a nice safety mechanism to keep me and others from shocking ourselves. And then I will turn on the power source, 100 volts, 400 milliamps, 45 minutes.